I'm Bill Longman. Welcome to Kick Close Up. Today we're going to take a closer look at Xilinx's Kria.
All right, so we're going to start here with the starter kit. Let's open it up. And you can see we have a little flash memory card. Nice little label. And then inside we have our development kit. Okay, so our FPGA is actually on a module, and this carrier board provides access to all of the various peripherals. We have a standard GPIO header over here, Ethernet support, which is in here, high-speed USB, HDMI, and power. And along this side, we have four PMOD connectors. And for high-speed Ethernet, you can drop in a module to go in there. You can add a video interface right here with the SLVS interface. And there is our JTAG header.
This is the module that's underneath that fan and heatsink. It's the Kria K26 system-on module, and it's built around a Xilinx Zinc UltraSkill Plus MPSoC device, and it's designed for production use. The UltraSkill Plus consists of two major components. One is a fixed processing system that includes things like a quad-core ARM Cortex-A53 for general computation work, a dual-core Cortex-R, which is designed for real-time support, and a graphics processor, a GPU, the Mali 400 MP. It also has all the standard interfaces that we saw on the carrier board, for example, the USB 3, SATA, and Gigabit Ethernet, CAN interface, SPI, and things like that. The high-speed interfaces like the 100 gig Ethernet are part of the programmable system, which is actually an FPGA, and that is where you get most of the power and flexibility of this system. I did take a look at some of the sample applications, and one of them utilizes time-sensitive networking support. It actually implements this using the FPGA support in synchronization with the rest of the fixed hardware. It utilizes the PMOD connectors to provide access to a temperature and humidity sensor, which is going to provide some data. In addition, the timing details are exposed, and we're going to be taking a look at those via the digital analog discovery studio that I have as an oscilloscope. Now, it does take a little while for the two systems to synchronize, but once they are, they can essentially operate in a deterministic fashion because effectively they have the same clocks running. And in the demo, it winds up then reading the temperature and temperature and humidity information and shipping that across to the other side where it can then be processed. Movado is the tool for programming the FPGA. The latest version utilizes machine learning to optimize the system implementation, and it's possible to use predefined solutions without using Movado directly, which is what I did with the demo. Still, Movado is where you're going to wind up customizing the hardware. Vitesse is the open source platform that is going to be used by most developers. It utilizes the hardware configurations that would be generated by Movado, and then the platform is used to create domains, which are configurations, and finally applications, which can then be debugged and essentially utilized on the hardware. Now, this robot starter kit obviously is designed to run on robots, among other things. And one of the things that it can run is the robot operating system. This would actually run on the hardcore processors. But The acceleration tools that are provided allow things like advanced processing of the video and adding AI support. Thanks for watching Kit Close Up. Check out our other videos and more coming soon.